the time series part. Last weekend, I covered last weekend, since prior to last weekend, right? So I covered the K-means algorithm and hierarchical clustering, and also we discussed about what else we discussed. Those kind of things we discussed, right? Anyhow, I'll send out the list of the consolidated list of algorithms that I covered so far, probably at the end of today's session. Okay, so that it will be helpful to keep track of it. Now we'll start with understanding what is the time series is all about, and also followed by that we'll continue with the market basket analysis. Let me just check if I have this. Somehow I misplaced it because I just replaced my hard disk recently. Somehow, yeah, it's good. It is there. The market basket analysis is also available. Fine. We'll start with the time series. So time series. What is time series algorithm? Just give me a second. Another guy, the previous batch, is calling me. Somehow he missed. See, it's a very simple algorithm, the time series algorithm. But if you go through the internet, it's a bit challenging to understand that. But nowadays it is good because most of many blogs are available, not like the 5 years back, right? Like in the 5 years back or 4 years back, only you find one or two study materials or videos. Very difficult to understand the end-to-end part of the time series, the forecasting thing. Okay. See, in the case of linear regression, what we do is you have a bunch of independent variables and you have the dependent variable. And let's say, the y is your dependent variable and the x is your independent variable. If you have multiple independent variables, you will be having, we call that as x1, x2, x3, x4. So y is a function of the x1, x2, etc., xn, right? So that is a regression analysis. Similarly, in logistic regression also, right? The y is a function of your independent variables. Let's take a simple example. In the case of stock price prediction, if you want to predict stock price, what are the factors do you think will be helpful in terms of forecasting it? See, before you answer this, I have another question. I have one question for you all. Okay. So, what is the difference between the prediction and forecasting? Any idea? Anybody has any idea? Prediction and forecasting. It's a debatable thing. Different people have different understanding around these two terms. Okay, some people say both of them are same. The prediction and forecasting, both of them are same. But in general, the prediction is for long term. Okay, long term, and forecasting is in general, it is for short term, right? So, for example, I want to predict the stock price for the next 10 days, or next 5 days, or next 15 days, or last quarter. Based on the last quarter data, I want to forecast the upcoming quarters revenue forecasting. If you want to do some revenue forecasting, demand forecasting, right? Anything which is short term, that is what in simple term called as a, roughly speaking, that is what called as a forecasting. Prediction is, long term, okay, long term kind of thing. So you know very well, in the case of prediction, there are two types at a high level. One is the real time prediction, another one is batch prediction. So the batch prediction is for, right, you take you trained your model for the last 2 years. In the case of bank, they have huge number of customers, right? They need to take more data and they need to train the algorithm, and they want to predict the future, this thing, right? So any new customer comes in, whether are they going to default or not, some or any fraudulent transactions. In order to identify that, yes, they need to train the model. It's kind of actually the fraudulent transaction anomaly detection. These are all the real-time prediction. Okay, I don't want to confuse you with the real-time as well as batch at this moment. The right, because most of them will get confused. See, if I say forecasting, which is short-term, so then is that different from the real-time prediction, right? So that you just hold that thought. We'll discuss it later. Anyhow, tomorrow I will cover the deployment part, and during the deployment, we'll discuss about this. Okay, what is real-time prediction and all these things. With some examples, I will tell you. Now, forecasting is at this moment, you just think, right, it is short-term. Prediction is long-term. So, okay, going back to this example, right? In the case of stock price prediction, what are the factors that are helpful in terms of predicting the stock price? Which factors that can influence the stock price? The performance, right? One of the key aspect is how well the company is performing. How well the company is performing? Are they really doing good job? Or are there any more political drivers, right? See, Trump, he stepped out, right? He stepped out. He stepped out, right? And because of that also, right, there could be some stock prices can go down. And the company performance, right? These are the factors, market drivers, and market drivers and political drivers, and this one, right? The company performance, right? See, the political and markets. These are, rarely it can happen. It will not happen on a day-to-day basis. But now you tell me to predict the stock price, what are the factors that are required? Forget about the odd situations like, the market drivers, some riot happen or some problem happen. Forget about this. Let's in the case of idealistic scenario. So what are the factors that are helpful in terms of predicting the stock price? Supposing you want to invest money on this Infosys stock. Okay. So before investing, you want to be very smart. Okay, you want to make a forecasting, and then based on which you decide whether you want to invest the money on the Infosys equity or Wipro or something else, right? Based on which you want to decide. So now, in order to forecast the stock price for Wipro or something else, right? Some other companies, what factors do you think will influence the stock price? Forget about the riot, other things, okay? The odd situations. Tell me something, no? See, if you want to predict stock price for the next couple of days, probably you would be wanting the quarterly revenue of Infosys, the market cap, and maybe some macroeconomic factors. What do you mean by macroeconomic factors? Something like GDP of India and inflation rate. So these are the factors definitely impacting the stock price, right? So you can run regression analysis. The problem with this regression analysis is stock prices changes on a daily basis. But how do we get GDP on a daily basis? It doesn't change on a daily basis. Even if it get changed, it doesn't get reported on a daily basis. Similarly, when it comes to inflation rate, it doesn't change on a daily basis. You have a stock price on a daily basis, and then you have GDP inflation not available on a daily basis. Right? So then using the features, using the independent variables such as GDP, inflation rate, that doesn't make any sense because those values you will not get it on a daily basis. That's the problem number one. The problem two is that the regression models are good for long-term forecast, whereas for short-term forecast, many time regression, the time regression is not a good technique, okay, to forecast next few days. So that's where the time series, comes into picture. Okay, it models the time series model, right? The algorithm, it models just a single variable. And we call that as a univariate time series, which means if you have a stock price, you don't need anything else is required to forecast the stock price. Let's see, your stock price is 100 today, and it was 103 yesterday, and day before yesterday it was 110, and prior to that it was 120, and so on. So using the historical data, you'll be able to predict the future value of the Infosys stock price or Wipro without having to look at the factors like GDP and other things. Okay, so that's why it's known as univariate time series, and univariate means only one variable. When it comes to time series, in the case of, as the name suggests, the univariate time series, you don't have to have the independent variables in simple term. So that is the difference between the regression analysis and time series. Okay, if I don't have the independent variables, how can I predict? So what happens when it comes to univariate time series, right? It considers yesterday's price itself as an independent variable, and day before yesterday stock price as an independent variable in order to predict tomorrow's stock price of your Infosys or Wipro. Okay. So using time series, you're also using some factor x1 that could also be possible, right? That we will see later on. So now let us focus only on the time series, okay, the univariate time series. You can do forecasting at an eye level using two different techniques. One is the statistical ways. It is some sort of estimation, some sort of regression, okay, some derivation of the, right? So you have something called the auto regression and moving average, and the combination of both auto regression and ME moving average, and ARIMA, the auto regression integrated moving average. So these are the statistical way. The advantage of doing forecasting using the statistical way is more accurate, but it takes time. It takes time. And other technique is the computational ways. I would say no computational way. It simply takes the previous value and it add it up. There is no statistical estimation as such. Okay, here we have something called exponential smoothing, Volt-Winter techniques are coming into picture. There will be more non-parametric, whereas AR, MA, ARMA, and ARIMA are parametric. Okay, the computational way of doing forecasting, such as using the exponential smoothing, Holt-Winter technique, right? The accuracy is not that good. This can be very simple, and it can take very less time, right? But the accuracy is not that good, not impressive, right? So now we will see. One second. Okay, the accuracy is not that. So that's where we'll be, using the statistical way of making a forecasting. Okay. First of all, right before we jump into using the statistical way of, one second here. Okay, I use that one, right? I recorded there also. Don't worry. Oh my God. Okay. Okay, so in the case of time series, before we jump in, okay, and the right before we jump in understanding what is the statistical way, what is auto regression, all the things, right? What we will do is let's try to understand what exactly time series is all about. So time series, is a collection of data points collected at constant time intervals. There should not be any gap, between the time that you gather the data. Okay, it should be equally spaced time intervals. When you collect the data for the forecasting, it should be an ordered sequence of numeric values, and it should be measured over equally spaced time intervals. The whole idea is to identify the internal structure or to forecast near future events based on recent history. Okay, right. So the what the see essentially there should not be any gap. That is what the point here. That is what you need. Yeah, that is what you need to remember here. Right? There should not be. See, let's say I want to forecast the Infosys stock price for the next 5 days. Right? So for that, I've taken last week data. So what is my last 5 days or last 10 days data I've taken? Yesterday's stock price of Infosys, and day before yesterday the stock price of Infosys, and prior to, let's say, last 10 days or daily Infosys stock price I have collected. Now the question is, I have only the 9 days, last 9 days data is available. If you have last 9 days data related to Infosys stock price is available, it is good. But make sure there should not be any gap in between. For example, first 3 days data is there, fourth day is missing, but fifth, sixth, and rest of the days data is available. No, there should not be any gap here. The sequence of data points in successive order indexed by time. That is what it says. So today's price or today's price, yesterday price, day before yesterday, and prior to day before yesterday. There should not be any gap here.
Sir,
This
I
is
have
the
a question.
prerequisite.
Am
Yeah.
I
Who is
audible?
there?
Hello.
Yeah. What is the question? Hello.
Yeah. Question is like market hours will be like from morning 9:15 to afternoon 3:30, right? We will be having a gap in between the days itself, right, sir? So how we will be managing that kind of scenario? Or it should be fine having some set of data for particular day.
Who is this? Who was this?
Deepak.
Yeah, Deepak. Yeah, tell me, Deepak. Yeah. You tell me what
So,
was your market time is?
so market time is normally it will not be there continuously for 24 hours, right? So there will be a gap between one day to another day. Like evening 3:30, market will get closed, and next day 9:30 it will open. So in that case, like
See, I'm
will
not
be
talking about intraday. I'm not talking intraday. Okay, I'm talking about next 5 days or what is the price. Okay, let's say see what is today's closing price for. I'm talking about yesterday's closing price of your Infosys, and day before yesterday closing price of the Infosys. I'm talking about the closing price.
okay.
All
Got
right.
it.
Okay. I'm not talking about intraday. Yes. In the case of intraday, every minute, there is a volatility, right? I'm not talking about the intraday forecasting. I'm talking about the next week forecasting. I'm doing forecasting for the next 5 days or next 6 days. Okay. So in that case, I'm talking about the closing price of your Infosys stock price for the last 5 days or last 7 days. Okay. Right. So in that case, make sure that you are not missing any single day. Right. Let's say you are taking 5 days. Let it be there. But right, don't say third day stock prices. I don't have the stock price for the last. The third days thing. Okay. Right. So even if you take 5 days or 7 days, make sure that it is in the successive order. There should not be any gap there. Right, so it's a collection of data points collected at constant time intervals. Right, that's why I made that statement. It is time dependent. The time series is it's a time it's a time dependent one.
Uh, Sita, can I ask one question? This is Srijit.
Yeah.
So regarding the question is that sometimes the seasonality also impact the impact the price movement also. So that moment, how we are going to calculate
Yeah,
that?
most time series have some form of seasonality trends. Okay,
Hmm.
variation specific to particular time frame. Okay, for example, if you see the sales of a woolen jacket over time, you will invariably find higher sales in winter seasons, right? So because of the inherent properties of time series, these are various steps involved in, right? There are various steps that are involved in analyzing it. So we'll discuss it later. Okay. Yeah. So how to, deal with those kind of trends, right? So when it comes to time series, it makes an assumption that, right, you should not have, we need to address the trends there. Okay. We should not have any trend, and make sure that you are not having something like what is that stationarity. Yeah, it makes assumption time series analysis. It makes an assumption of stationarity. We'll discuss about stationarity. Let's go step by step. Okay, let's not jump here and there. So time series, the components of time series. These are the four components of time series. We know trend. The trend component talks about the upward and downward movement, right, in the average value of the forecast value over a period of time. And cyclic is somewhat like upward and downward movements in the variable value, right? So there will be some kind of oscillation, right? It exhibits oscillation which do not have a fixed period but are predictable to some extent, the cyclic thing. Okay, and seasonal, yes, we know very well every year particular time, right? Particular month or particular week of an year, there will be a peak in sales. And also in the case of the winter season, which items, right? When, see, we know very well it's a fixed time period, right? So when it comes to seasonality, um, it is right. It is it is it's kind of a fixed duration when it comes to seasonality. So summer certain items will be sold high, and winter only specific items will be sold high. And we know very well here, right? So more sales in a department stores during festival, Christmas, and that is called seasonality. Okay, so it is a fixed time period, and irregular is something like there is some sudden riot happen, earthquake happen, right? Suddenly the prices can drop, suddenly the prices can go high, or somebody says, right, the chief minister is very critical, anything can happen anytime. So what the public will do, suddenly they'll rush to the mall and they buy as many items as possible, because after the demise of the CM, anything can happen, right? That is called irregular component. Seasonal component, we know very well. These are the four different components of the time series. So in the case of trend, right, the demand consistently increases or decreases over time. When the price increases, sometimes often the demand can fall down. And also this one, the demand consistently increases. Sometimes, right, the demand will increase, and this is called stationary data. Okay, demand seem to cluster around a specific level, right? This is called stationary. It is also called no trend. If you don't have the trend in your data set, we call that as a stationary. See, this is what the trend, right? Upward is a trend. We could see, constant increase, and there's a constant decrease in price, stock price, something like that, right? This, we could see some kind of pattern, the trend here. But whereas here, there is no trend here. So univariate and multivariate time series. So I'm going to talk about univariate. When I discussed about univariate time series analysis, right? I was telling about this one. You can use only one variable. In a single variable, you can use it. With that, you are going to do forecasting for the upcoming days. But in the single variable, right, the yesterday price will serve as a dependent variable, roughly speaking. Okay, and prior to, say, day before yesterday, a stock price will serve as the dependent variable in order to predict your tomorrow's price, right? In the case of univariate time series, what if I have so in that case, can't I use multiple variable, more than one variable, in order to do forecasting? Yes, you can do that. That is called multivariate time series. Srijit, why don't you tell me, did you use multivariate time series? You've been doing forecasting for quite a long time, right? Now I recollect. You told me long back. We have something called VAR, right? Still, yeah, you can do multivariate time series analysis also. There is a technique called VAR, okay, using which you can do it. See, well, let us try to understand the terminologies, okay, and or correlation, autocorrelation, and partial autocorrelation. So we'll be using something called ACF and PCF, PSCF correlograms, right? The chart, using which we'll try to identify the optimal value for the AR component and MA component, moving average component. Don't worry about these things. I will explain you and I'll give a demo in R so that you'll be able to understand these things. It's a very simple one, okay? And stationary time series. What is stationary time series? The stationary time series, one with constant mean and constant variance. It'll have the constant mean and the variance also constant. Both of them are constant. Please remember this. Right, and we have something called white noise. Um, right, we'll discuss about white noise later. Okay, if you know this much, it is enough. Uh, what is autocorrelation and partial autocorrelation? So, are there any correlation exists between today and yesterday price? Correlation with lag minus one, lag two, and lag three. Are there any correlation exist? What is lag minus one? Yesterday price. Lag 2 is day before yesterday price, and lag 3 is prior to day before yesterday. That is what it says. So let's see if I say a lag of YT minus 1, right? Which one you'll be using it to do forecasting? Lag of YT minus 1, which means yesterday price. In that case, lag of YT minus 2. You will be using day before yesterday price in order to do forecasting for yesterday thing, right? That is how we'll be doing it. So in this case, yeah, autocorrelation. So in the case of autocorrelation, are there any correlation exists between day before yesterday and yesterday and day before yesterday and prior to day before yesterday? Are there any correlation exhibited? So the partial autocorrelation, what it says is, it is not fully correlated with the past price, right? It is used to identify the extent of relation between current values of variable with earlier values of that same variable, right? So values for various time lags. For instance, today's price and day before yesterday price, while holding the effects of all other time lags constants, right? So thus, it is completely analogous to partial one, but refers to a single variable. So in this case, at least uh, today price and day before yesterday price, are there any correlation exists? Partially, some correlation is there, but whereas in the case of auto correlation, right? The day before yesterday and prior to day before yesterday, yesterday price, are there any correlation? That is what we are going to check it. And using these for this autocorrelation and partial autocorrelation, we have something called correlogram. We can generate a chart correlogram using which we can come up with the optimal value for the P and Q. There are two components or two arguments as part of your ARIMA function. Okay, and yeah, these are when right, these are the simple use cases. If you want to predict the or forecast the sales trend and current sales revenue and profit data and level debt carried by the company, right? So these are the situation factors need to forecast the stock price of Mahindra and Mahindra, and in that kind of situation you'll be using the forecasting technique. Many time series, right? Box and Jenkins in particular assume stationary sequences. Most of the time series analysis, it make an assumption of time. This is what I told you a while back. Right? So in the case of stationary sequence, the mean variance and autocorrelation do not change over time. Okay, now the question is, in case of any change in mean and variance, what should I do? In that case, can't I use the data? Still, you can use it, but you need to do some kind of detrending. You need to do some kind of detrending and seasonally adjust the data. You use detrend and seasonally you need to adjust the data. Right. So in general, we have some option in ARIMA function in order to, transform your data to stationary by doing differencing. Right. So the ARIMA, the first part is auto regression, and MA is nothing but moving average. The I is nothing but the differencing. Okay, differencing. Don't worry, right? Rest you will be understanding it little later. Okay. I'll directly jump into this one. ECF and so that's what. In the case of, see, we have a function, we have method or function called ARIMA that is available both in Python and R, right? Using which we can do forecasting using ARIMA. So AR stands for auto regression, MA stands for moving average, I stands for difference. Okay. And the argument for this function is PDQ. P stands for, this is for AR, and Q is for MA, and D is differencing. Okay, don't think anything beyond this. Okay, you will get confused, right? I guess, yeah, most of you are beginner, right? You are completely new into forecasting. So the beginners, I would suggest you don't think anything beyond this. At this moment, you just understand there is a function or method called ARIMA is available. All we need to do is we need to specify the value for the P and Q and D. Now the question is, what value can I specify for P and Q? What is P? P is the number of autoregressive terms, right? And so how many number of lakhs that I should use it? So yesterday price, day before yesterday price, and prior to day before yesterday price. I need to use 3 lakhs. Right? The linear regression of the current value of the series against one or more prior values of the series. Last 3 days stock price, Infosys stock price, I want to use it. Let's say 3, right? And D is the number of non-seasonal differences. So why we use D is, in case of any non-stationarity is there in my data set, using D is nothing but differencing. By taking the difference, you're converting your data set into seasonal. Don't worry, when I give you a demo, you will be able to understand very clearly. Okay. And Q is nothing but number of past prediction error terms used for the future forecast. You see, today price is 100, and yesterday stock price of Infosys is 105, and day before yesterday was 110. But that was the predicted value for the Infosys stock price. 110 was the day before yesterday. But what was the actual one? Let's say the actual one was on the day 105. The difference is 5. That is loss, right? Which is nothing but error. The actual minus predicted is called error. We discussed several times. Actual minus forecasted. That is what called as error. So error 1. See, today's price. What is the error on yesterday? The actual price of yesterday's stock price of Infosys and the forecasted Infosys stock price. Actual minus forecasted. Yesterday Infosys stock price. Okay, and prior to day before yesterday. Prior to day before yesterday. Right. So what is the error 1, error 2, error 3? How many number of error terms that we are supposed to use it for the future forecast? That is what you need to specify it here. Okay. And this is the equation for ARIMA model. This is kind of your intercept, right? So here 5-1, and this is lag 1, lag 2, and so on. How many number of lags that you are supposed to use it? Yesterday Infosys stock price, prior to day before yesterday Infosys stock price, and so on. And this is your AR term. The next one is, this is also constant term for the error, okay? And here the yesterday's error, prior to day before yesterday error, right? Let's say yesterday's stock price of Infosys, you forecasted and told me, Satya, we are, as per my model, the forecasted price is, let's 110. But actually on that day, right, the closing price, let's the closing price of the Info stock price is 115, right? The actual is 115, the forecasted was 110, right? The difference is 5 plus 5, right? That is what the error. So what was the error yesterday and prior to day before yesterday, and so on. So you have AR term and you have the moving average term, right? So, but here the I stands for differencing, which we'll see it as part of my demo, okay? P is the number of autoregressive terms, D is the number of differences, Q is the number of moving average terms. Arima adds a differencing term to make the series more stationary. The rule of the linear trend can be removed by D equal to 1. You can say differencing is 1, and if you have quadratic trend, you need to use 2, and so on. But this you will get to know as you keep building or do when you keep do a lot of forecasting, right? By practice, you will learn this one. But this is the rule of thumb. And next one is how to interpret the correlograms, right? So how to interpret the correlograms. So that we will see it as part of the demo session. Okay, I'll just jump into, or here something is missing. I'm going to install this package. It takes for a while. Let's wait for a few minutes, but it will not take much time. Okay. See, in Python, we have something called stats models.tsa.stat models. Okay. See, in Python, you have something called, I'll just update it here. You have a package called stats models. See, the stats models is the package which is used to perform the statistical test, okay, and including the forecasting, okay, time series thing. And as part of that, you have something called the augmented Dickey Fuller and all is there in Python. Okay, we use stat tools as part of stats models package to do this one. Okay, to implement the time series model. Okay, now what we will do is, see here, I ingested this data file. Oh, okay, nifty.tsv is not there. 1 second. Oh, it is in stew folder. Okay, stew. Yes, we are done with this. I'm going to view the data that are stored in my data frame called DF. So these are the data set, and let us view it using this option, the tabular format. Okay, so what is the price for specific the Infosys or something like that, okay? So specific company stock price on a daily basis, and returns. We have two columns. One is prices and returns. So we will forecast the stock price as well as we'll forecast the returns also. If I invest, what is the what is the forecasted stock price? That is one aspect. Okay, what is the return am I going to get? Okay, that is also we are going to do forecasting. So first, what we are going to do is I'm going to import the library called T series. T series stands for time series. Okay, it is already there. Some warning we can ignore it. As long as there is no error, it is fine. So ADF dot test, which is nothing but the augmented Dickey-Fuller test. We are going to conduct a test called, before that, what I'm going to do is we have two columns. One is price, other one is returns. I'm going to plot it now. Before I conduct this test, I'm going to plot this now. Price is not found. Okay, why? Okay, I need to attach it. See, in OR, if you wanted to use a column, you need to prefix the column with the data frame name dollar, right? DF dollar prices. What I do is I use a function called attach DF. So what it does is it will attach. So what it does is it will give a reference to my columns. Okay. So in this case, you don't have to specify DF dollar. Okay, if you use attach, you don't have to use it, but it is, we don't use it use attach most of the time, because if you have multiple data file and if those data files have similar columns, there will be some issue there. Okay, but since we are using only one data file, I use attach. If I use attach, I don't have to do this prefixing thing. Okay, a data frame name dollar column name, I don't have to do it. One second. My system is hanging. Just give me a second. I think I mistakenly pressed my tablet. Yeah. Look here. I'm going to remove this one. I don't need it because I used attach function. Look here. This is the plot. I plotted the price column data here. Price column data here. Here I could see. Can you tell me, is this, can you see any trend here?
It's upward trend showing. It's showing an upward trend.
Upward trend. Very good. It shows an upward trend. Good. The price is right. It goes on steadily. It goes up. Right. We can see upward trend. Now, can someone tell me, is this a stationary data? Right? Because the ARIMA model makes an assumption that your data is stationary. What do you mean by stationary? Data is supposed to be right. The mean and the variance supposed to be constant. The mean and variance are supposed to be constant. Only then your data is considered as stationary data. Only if your data is stationary, you can fit a ARIMA model. Now you tell me, one second, I don't know why it is hanging here. Yeah, so look here. Listen very carefully. It is very simple one. Let's take this data set. So what is the mean here? 1 second. What is the mean here? Somewhere here, right? Mean is the middle value. You take this bunch of data, the mean will be somewhere in the middle. You take this data set, the mean will be somewhere in the middle, right? The mean is somewhat constant here. The variance also, obviously, if the mean is constant, the mean will also be, the variance will also be more or less constant. But if you look at here, the mean of this data set is different from this one. The variance is also different from this one, right? You all agree with me, right? Hence, this is a non-stationary data. By visually looking at this column price, we conclude that the price data is not stationary. Hence, it is not right. It is not It is not helpful to fit my ARIMA model. Why? Because my model, ARIMA model, makes an assumption that the data should be stationary. And so in that case, what we do is we need to convert it as a stationary data.
Sir, may I ask one question regarding this data set?
Yeah.
So suppose I'm working on a data set. Now I'm not sure that all the data provided in the data is correct. Then how can I check that this all those data are correct, or there may be incorrect data involved in it?
That is a good question, right? If you are, that is where you need to do data exploration. That is data related issue, right? Missing data. You're talking about missing data, outliers and all, right?
Yeah, someone maybe provided incorrect data, like other stock data involved in it.
That's what. See, that is a different story altogether. That is related to data quality issues. Okay. Let us assume that the data what I have is, whatever I have in my hand is, it is a clean data. We did cleaning or it is clean data. Yeah. When you get the data, you need to first explore the data, right? You need to first check, are there any outliers are there in this data set? If it is an outlier, you need to check whether it is a valid outlier or or is it something wrong. Okay, let's see, the yesterday stock price for Infosys is 1800, and let's say today's predicted stock prices, the forecasted stock prices 5000. Then there is a significant difference. Significant difference. See, in some cases, what will happen, like you said, there it will not be significant. Some data issue will be there, right? So that's where you need to work along with the business stakeholders, right? Or you need to get their you need to vet it, right? You need to vet it with them. So whether the data, whatever you are using, it is correct data or not. Okay, see that, right? With the domain knowledge we can do it. And also nowadays all the stock prices are available in the internet for all the companies. You can download it, you can do some kind of you can use minus operator, right? Minus operator with the data what you have it in your hand, and the what data is available in Yahoo, right? Yahoo, and what is the other one here? CNN, right? Even they provide the data. Download it and compare them. In case of any discrepancy, you can fix it. That is a data quality related issues. That is a different topic altogether. But still, we will have one more session for that one, right? I am going to cover a complete session regarding the data pre-processing. As part of data pre-processing, what are the tasks are we going to do it? Like discretization and addressing the outliers, what technique we can use it to address the outliers, and how do we perform the label encoding, when we are supposed to perform label encoding, and when we are supposed to perform one-hot encoding, and when we are supposed to perform Hercules encoding. Likewise, different types are there. We'll discuss it in a separate session. Okay. At this moment, you assume that the data is clean. Okay. That we will discuss it later. Okay. So now, by looking at this plot, it is quite evident that the price column has a trend in it. It is not helpful to fit my ARIMA model to do forecasting, because the rule is the data what you have it to do forecasting, it should be stationary. So okay, just by eyeballing this, we are able to make out. Still, to double check whether it is really, are there any trend is there, we are statistically also, we are double checking it. We use a test called augmented Dickey-Fuller test, ADF dot test. So here the first argument is the column name. Alternative is equal to stationary. Alternative hypothesis. Okay, I'm going to execute this one. As I told you, as I've been telling you, if if you conduct any statistical test, you use R, Python, or any other statistical software, even SAS, right? It gives you the p-value. If the p-value is less than alpha, you are going to reject the null hypothesis. If it is not, then you are going to accept the null hypothesis. Okay. So here the alternative is stationary, right? And here the p-value is, see, what is my alpha value? Alpha is there on top of my head, right? Alpha is, always just remember alpha is 0.05. Okay. P-value is obviously not less than the alpha value. Here my p-value is 0.95. 0.5, does 0.95 is less than alpha value? No, right? It is greater than this. Hence, you fail to reject the null hypothesis. What is my null hypothesis? Non-stationary. Alternative is stationary. Right? Only when I reject the null hypothesis, I can say, yes, it is stationary. Since my, see here, by default, H sub 0 is nothing but the null hypothesis. What is my null hypothesis? The non-stationary. Right? Alternative is, that's why I mean, there is a class, there is a parameter called alternative. Stationary, I mentioned it here. Okay. So here by default non-stationary, but don't ask me this question. Can I specify non-stationary here? Okay. But this is how we use it conventionally. Okay. You're supposed to specify stationary only here in the alternative. Okay. Let us not get into that confusion now. The simple thing is, if you are able to reject only when p-value is less than alpha, you are going to reject the null hypothesis. But in our case, the p-value is not less than alpha. Hence, we are not able to reject this one. We are going to say the given price column is a non-stationary data. Visually also we confirm, statistically also we confirm the price column is not a stationary data. So in that case, can I simply say I cannot do forecasting? No, still you can do it. For that, you need to do a simple transformation, convert the non-stationary data into stationary data. How do I do that? Differencing. Thank God there is a built-in function called diff that is available. How many of you remember we use diff function in some other algorithm? How many of you remember? The last session we discussed, right? When did we use diff? Oh, sorry, we did not use diff. We used the dist function. Yeah, dist function is distance function is for, we used it for this one, the hierarchical clustering. Okay, so difference, what it does is subtract today's price with yesterday price with prior to yesterday price. Okay, we are subtracting the prices. Basically, we say differencing. We use a term called differencing. You right? Okay. So after doing differencing, I'm going to we see the difference price is stored in a variable called d dot prices. Okay, and if I plot the prices now, d dot price, different prices. Now the data became stationary. Look at here. Take this data set. Where is the mean here? Rishik, it is there in the middle, right? If you say average will be there in the middle. You take this data set, the average will be somewhere here. You take this data, the average will be somewhere here, right? The mean is constant, somewhat constant, and the variance is also somehow constant here. Hence, it is a stationary data. How did we convert the non-stationary to stationary? By taking the differencing. Sometimes Even after taking the differencing, it will not get converted as stationary data. You need to take one more differencing. Like here, see, we have taken differencing on the price and we stored it in this variable. You take the differencing once again on this column, on this variable. Most of the time it will become. So now my data is stationary. It is good enough. My current data is good enough or sufficient enough to fit my ARIMA model. Fine. Forget about this one. Now let us use a function called ARIMA function. ARIMA and the difference prices. Here what I do is I use the parameter called order equal to, this is for P, this is for D and Q. So how many days of the stock price I'm taking here? Only one day, yesterday price. I'm not going to do any differencing because already I did the differencing. And moving average, what is the error? Don't take any error, right? I'm going to fit this one. Simply you look at the AAC value. The lesser the AAC, the better the model. So now what I'm going to do, I'm just playing around by keep changing the value for P, D, Q and all. And let us check the AAC for each and every model. This model's AAC is much more than this one. We'll try this one. This is the manual way of doing it. 214 to 0.94. Still it is more than this one. So now now what we are trying to do is we are trying to find out the optimal value for PDQ. So fortunately there is a built-in function that is available in our auto.arimo. Okay. So here I'm going to simply I pass the detrended, which is nothing but the stationary data, to my auto.arima. If you look at this AAC value 2133.62, compared to all the other model, it is very less. Hence, it is the best model. It is kind of the stepwise regression. How many of you remember stepwise regression? In R and Python. So R we discussed about stepwise regression because in Python we don't have stepwise regression available. The built-in function is not available. But still, you can create your own custom function. For that, you should be knowing what is backward stepwise regression and forward stepwise regression, right? But in Python, we have something called RFE, recursive feature elimination, that uses the backward stepwise regression, right? Fine. So it is somewhat similar to stepwise regression. If I use stepwise regression for linear regression model, it tells me which independent variables are good enough to include in my model. Similarly, auto.arima function tells me the values for PDQ. Don't use anything zero and you take one more differencing and then use last 2 days errors, error 1, error 2. This is the recommended values for PDQ difference. One means difference. Take one more time the difference. But we thought after taking the difference one time itself, it became stationary by visually looking at it. And even with the, I did not conduct the augmented test, right? Let us do one thing. We will conduct the augmented test for this. Yeah, we'll check for statistically also will confirm whether the given the difference data is significant or look here. The p-value is 0.01. So p is obviously less than alpha. 0.01 is less than 0.05. Hence, we reject the null hypothesis and we conclude that we have sufficient evidence that the given data is stationary. After we did the differencing, we could see that statistically and visually also that the data got converted as a stationary data. But still, what the auto.arima says is you need to do one more differencing. Right? So this is the optimal value that is available. It's a plain vanilla. You don't have to break your head by randomly changing the value for these two, right? Like we use grid search as part of hyperparameter tuning. We'll discuss that later. Don't worry. I will cover that one also now itself. Okay. So you don't have to do some grid search, right? So we have the built-in function that is available to give you the optimal value for PDQ. That's it. Next, what we will do is we have one more column, the returns column, right? Now let us plot the value for the returns column in the chart. Now you tell me whether it is stationary or non-stationary. Rajesh or Rishik, Deepak. Is it stationary data or what do you mean by stationary data? The mean and it is supposed to be constant.
Not stationary.
Huh?
It is stationary.
Hello?
Stationary, sir.
Sorry, could not hear you. Your voice is very feeble.
I'm saying it is stationary.
It
Stationary.
is stationary. It is stationary, right? It is stationary. Okay. So in this case, it is stationary. Okay. So this column is stationary because the mean, and if you take the mean will be there in the average is there in the middle, right? All the time. If you take this data and this data and this data, it will be somewhere in the middle only. Or if the mean is there in the middle, obviously the variance will also be there in the middle, right? So it will also be constant. So usually we concluded that the returns column is a stationary data, and statistically also will conclude that we use augmented Dickey-Fuller test. All we have to do is just look at the p. P value is 0.01. Rishi, can you tell me, can you reject the null hypothesis here? 0.01 is the p value. My alpha value is 0.05. Obviously, it is p value is less than alpha. If the p value is less than alpha, reject the null hypothesis. If you reject the null hypothesis, then you are concluding that the returns column is a stationary data. Fine. So both visually and statistically also we concluded that the given data is stationary data. Here you don't have to do differencing. Okay. But still, what we will do is right in the interest of time, I'm going to use auto.arima on returns because since this data is stationary, I did not do any differencing. So what is the recommended value for PDQ? 111, which is 111. The next step is obviously predict. Now your model got trained. So apply this model on the unseen data. And end out next 10 days, what is the predicted, right? What is the forecasted price? Sorry, here I did not select this one. Here the I got the optimal value with the help of auto.arima. So now it gives me the forecasted value, forecasted price. So this is how we perform the forecasting. Okay, very simple one. Okay, this is how we do it.
So just I have one question.
Yeah.
So just I'm asking, like stationary data you have, I'm running a algorithm that code and it's converting to from non-stationary data to stationary. So how does in backend it works actually? That on the basis of what the algorithm works to convert the non-stationary data to stationary.
Okay. So when you do differencing, what is happening? Any idea?
No.
It will subtract the price, today's price, with yesterday price, and yesterday price with the day before yesterday price. Okay? That is how it works. When it comes to the RIMA model, you don't have to worry about the under the hood thing. Okay, but if you know it is good, moving average. So how do you compute the moving average? So today's price and yesterday price we subtracted, and the subtracted value you use it, and again tomorrow price and today price you subtracted, that you will be using it, right? That is how it is computing the error and the this one. Okay, I will share you one link, right? If you want to take a deep dive, I will send you that so that you can go through on it and understand it. But you don't have to worry too much on this one because it's all nowadays, right? Everything is available with the built-in function. But still, they expect you the same thing, right? Behind the scene, how it works. So your question is how it gets converted as a stationary, isn't it?
Yes, yes, yes.
Right? So simple. We are taking the differencing. Differencing is you subtract today's price from yesterday price from yesterday price. By doing so, it
Cost
will
function.
become the price column data will get smoothened. What do you mean by smoothened? The trend will be removed, right? Yeah, I'll send you one. Otherwise, I'll send you some link. I'll send you a link, right? With some data, they explain it. Okay? That one will be helpful for you, right? Fine. So this is how the time series model works. But Python, I already, Srijit, did you download the one which I shared it long back? The Python forecasting thing.
Because I downloaded them. After that,
You check it. Yeah, you check it if you have it, right? The Python file you just shared it me somehow, right? I just replaced my hard disk. Somehow I missed that file. Probably I'll check in my previous GitHub folder. If it is there, I'll share it. Okay. And here, as I told you, right, we use stats models. In the stats models, we have submitted your TSA dot stats tools, and using which we fit the model. Okay. And we have something AD Fuller instead of ADF dot Fuller. AD Fuller function is available, using which you can conduct the test to make sure that whether it has stationarity or non-stationarity. Okay. Fine. Next, what we will do is we will. Okay, let me do one thing. Just give me 2 minutes. I'm getting so many messages from my office. Okay, I'll just put you in mute just for 2 minutes. Okay, and then we'll resume the session. Okay, just give me 2 minutes. The market basket analysis. Okay. When I don't know where I misplaced my study material. Anyhow, it is there. Don't worry. Market basket analysis is the very popular technique that most of the retailers they'll be using it. But not only the retailers, they are using the market and basket analysis nowadays. Nowadays, across the industry, everybody started using market basket analysis. For this, there is a rule called association rule. Right? Using association rule, you can perform market basket analysis. What is market basket analysis? It helps us to identify the association between the pairs of products purchased together. Let's say when the customer buys product A, which other item they tend to buy or purchase together with product A. Simple example is, let's say a customer buy a bread. Along with this, they purchased bread and milk. Sorry, the egg and milk. Along with the bread, they purchased egg and milk. Likewise, if you look at most of the customers, the same pattern, if it is there, right, then there is a association. Using market basket analysis. As part of market basket analysis, we are identifying the pairs of products that were purchased together. right? The co-occurrence of the pairs of the items, right, purchased by the customers. That is what we are interested in. So that, okay, by knowing this, what are we going to do? By knowing this, what are we going to do? Let's say customer is most of the customers, whenever they buy bread, along with it, they are buying egg as well as milk. By knowing this, what are you going to do?
We can provide recommendations.
Okay, what kind of recommendation? What kind of recommendation?
The supporting products are the main product we're going to get.
Yeah, recommendations, right? Like you said, customers, those bought this digitally. Let's say somebody is ordering in the big basket, right? Let's see, in the case of big basket, right? So customer, those bought this item also purchase so and so. You can do recommendation. You can do recommendation, right? You can recommend the right products, the right customer at the right time can lead to
We
the
can also
improvement, right? And the increase in customer satisfaction. The increase in the customer satisfaction is the key for the increase in, or that is the driver for your the boost in your sales, right?
or we can also predict the alternative sales volume of the other product also. Like if someone is buying egg, then what quantity of bread they can buy by analyzing their nature of buying habits.
Yeah, purchase behavior. Purchase behavior. Is that what you're saying? Sorry, I did not get you.
Yes, someone is like buying the bread, and how many percent of item who are buying the bread, they're also buying the related milk also, and also egg also alternative. So we can predict the sales of egg and milk on the basis of the by on the basis of the sales volume of the bread also.
Yes, yes, I got it. I got it, right? So the one is to identify, so by the objective of MBA is MBA analysis, right? Market basket analysis, to find out the items that were purchased together more frequently. That's the whole of it. But by doing this, what am I going to do? The one idea is we can make, like Sendil said, we can make a recommendation. Let's say I want to order some item in a big basket. Let's say I want to order bread, right? So what recommendation the app can make it? Customers, those purchase bread, they also purchase milk and egg. So when I look at this, oh man, okay, milk also we are running out of stock. Somehow he reminded me, better he recommended me now. So one way it helped me to remember, right? So better order milk and egg also. And if in case of any offer is there, that is another way of forcing the customer to spend more. By doing a recommendation, you are tempting the customer to buy more. Along with this, if you put a jam also, right? So most favorite items, right? These two items are my favorite. Supposing chicken nuggets, that's my favorite item, right? Chicken nuggets with something else, right? So that is my favorite item. Oh, obviously, I'll go and buy it. Right? You're tempting the another example is like whenever the customer buy, or those customers purchased a mobile phone, the mobile phone, they also purchased the tempered glass, and also they purchased the mobile cover. Recommend the customer so that the customer will be more proactive. Oh, thank God. What is tempered glass? They, right? It will it will arouse their curiosity, and they will go and check. Oh, it is good. One way it is good. I have kid in my house. Anytime she may take my mobile and she may scratch it on the floor. Anytime anything can happen to my mobile display. So you buy tempered glass. It will make the customers to buy the right product, right? To safeguard their investment. Let's say you are buying Apple mobile iPhone, right? And it is expensive one. And buying, no customer will hesitate to buy mobile cover and tempered glass, right? So one way you are favoring the customer to buy the right product at the right time, so that on the one hand customer will be happy, on the other hand you are tempting the customer to spend more from their wallet. And other aspect is in the case of in-store, you can come up with the optimal model. you have something like planogram. If you go to Walmart, all the Target or any large retail, even small retail also now they have planogram. Okay, even Nilgiris, right? They have some planogram. So you, by knowing this, if you keep these items together, what will happen is it will save the customer's time. Oh, I most frequently, whenever I purchase bread, I definitely purchase egg. By keeping these two items together, it will improve the customer's experience. They don't have to run from pillar to post to search for egg. In the case of Walmart, it's a very big mall, right? You don't have to run from one end to another end of the mall. If you keep the relevant items together, that will improve the customer's experience. The other examples, right? Whenever they buy the house, right? Those customers, if you get to know they purchased house, they definitely buy furnitures and car. Those customers they purchased car tires, yeah, tire TYR, right? Tires. They buy tires also. These items they purchase it more frequently, and yeah, by exploring the data, if you see more, the customers they purchase tires, right? That is called the next one is called next best recommendation, next best prediction, right? Next best item prediction. That is a different topic altogether. You can do that one also. The applications of association, you can use it in market basket analysis and recommender systems. People who bought what you bought also purchased, discovering web usage pattern. Those, you know, those people watched. In the case of Instagram, you see, right? You would have followed some of your favorite celebrities, and since you followed this celebrity, you may also like to follow this celebrity, right? Some kind of recommendation it makes everywhere. Now the association rule is used, and we have something else called collaborative filtering. We'll discuss it later. Okay, I'll also cover it, don't worry. So to implement the association rule, we have something called a priori algorithm is available. Okay, so a priori algorithm, appropriate association rule is used in MBA, market basket analysis. Now let us understand certain terminology. Frequent item set. You know item set, right? A set of items that appears together often enough. That is called frequent item set. Item set is nothing but a pair, right? Frequent pairs. Formally support. The meets a minimum criterion thing, and support is the percentage of transaction that contains the frequent items. You see, you purchased both bread and egg out more frequently. Let's say out of 10,000 transactions, if I take the last 10,000 transactions, how many number of transactions the customers purchased bread and egg together, right? Higher the support, it is good. That means those items are more frequently purchased together. The property of the a priori, any subset of frequent item set is also frequent. It has at least the support of a superset. You remember this. Any subset of a frequent item set is also frequent. The basic principle of a priori is any subset of frequent items must be frequent. Now let us look at this one. Items set, collection of one or more items. You need not to be pair. Okay. Sometimes they buy milk and egg with bread also. The whole idea is we want to find out the frequent item sets. The collection of one or more items. Item set is nothing but that one. The frequent item set, bread and butter. Look at this data set. If you look here, the bread and butter, bread and oh, here different, butter is not the right. Okay, here different. Yeah, look here. In this case, beer and diaper. Beer and diaper is the most frequently purchased items, right? Of this. See, these two pair out of the total number and how many times they purchase. 3 divided by 5. That is what you support. Association note, whenever they buy bread, they tend to buy butter also. So in this case, whenever they purchase beer, they tend to purchase diapers also. Weekend, right? Every Friday or so, you can see this trend in the Walmart, other things. They found the Walmart and other large big box retailers. They found this trend. Whenever the weekend comes, right? Friday or so, they tend to, whenever they buy beer, along with they buy diapers also. Okay. The support count, the frequency of occurrence of an item set, that is what the support count. How do we compute the support? How many number of transactions we can see these two items purchased together. 3 transactions out of 5. 3 out of 5. That is what your support count. So this is what the formula, right? Where if A probability of A union B is equal to the number of, this is, if you, instead of this, if you look at here, the bread and milk together, right? The number of times the bread and milk they purchase together out of the total number, and that is what your support. So that's what I said. Here, bread and milk, how many times are there bread and milk? 1, 2, 3, right? 3 out of 5 times. So n 60%. So what is the support for milk and diaper? See, in this case, bread and milk, the support is this one. What is the support for milk and diaper? Then you need to look at the combination of both milk and diaper. Milk and diaper, milk and diaper, milk and diaper. 3 times are there, right? So 3 divided by 5. Here also 60% only. This is how you need to compute this one. And we have something else called confidence. So here, look at this one. So bread and milk for this combination, right? The bread and milk divided by bread. Whenever they purchase bread, they purchase milk also, right? But here, the number of times they purchase these two things together versus how many number of times they purchase bread. So if you look at this bread, how many number of times are there in this transaction? 1, 2, 3 and 4. The denominator 4, and bread and milk is already we saw 3 times. 3 divided by 4 is 0.75. Now you tell me what is the confidence for milk and diaper? Deepak, Rishik and others, Rajesh, why don't you tell me what is the confidence for milk and diaper? Whenever they purchase milk, they also purchase diaper. Use the same thing. The milk and diaper, how many number of transactions are there? 3 times, right? And diaper, how many number of times are there? Here also 4, right? 3 divided by 4. 3 and 3 divided by 4, hence 75%. That is what confidence. And we have something called lift. Lift, let us not worry about lift now. And let us directly jump in here and understand how this a priori algorithm works. This one is, bear with me, okay? I somehow misplaced my PowerPoint. Okay, look here. There are 3 steps here. So in this case, the process starts with finding frequent one item sets, frequent one item sets. This is my invoice number. Just think this is my invoice number, and each invoice, not my invoice number, different people's invoice number we noted down here, and each invoice how many number of items they purchase. So this customer in this invoice, he purchased 3 items. Item 1, 3 and 4. In this customer, in this invoice, he purchased 4 items. What we are doing is we try to find out the frequent one item sets. Look at here. In this case, the item set 1, how many times it occurs? One is here, one is here, one is here. 3 times it occurs. See here, 1, 2, 3, 4 at the maximum. So how many number of times the item 1 purchase, how many number of times the item 2 purchase, how many number of times item 3 purchase, and vice versa, and so on. Okay. And here if you look at this item 4, we purchase only one time. Only one time. We have something called the minimum support count. We have a parameter called minimum support count. If I use minimum support count equal to 2, if I use minimum support count 2, that means at least, 2 times each item should have been purchased by the customers, so that I can consider those items were purchased frequently. So in that case, what will happen is this product has been purchased only one times. This one will get filtered out. So this item purchased 3 times, 3 times, 4 times, 4 times. Next time what I do is, the algorithm what it does is, then the process continues by using frequent one item to find frequent two item sets. First it started with frequent one item sets. Now it's trying to find out frequent two item sets and so on. What are the frequent two items? Now I wanted to know with this combination, 1 and 2 product, how many times they purchased it. For 1 and 2, 1 and 3, 1 and 4, 1 and 5. And similarly 2 and 3, 2 and 4, 2 and 1 comma 2 and 1 comma 5 and 2 comma something like, right? So you will find out with this combination. If you 1 comma 2, 1 comma 2 and 1 comma 3 and 2 comma 3 and 2 comma 5 and 3 comma something. Okay, if you look at this pair only one time, and rest of them are more than one. If you apply the minimum support count, this one will get eliminated. We wanted to know how many number of pairs were purchased more than once. So this pair they purchased more than once, The next step is, right, now what you are doing, third iteration, frequent answer for k equal to 3, pruning step 3. Now we take 1 to 3 and 1 to 3, 1 to 5 and 2, 3, 5 and so 1, 2, 3 and 2, 3, 4 and 3, 4, 5, something like, okay. So with this combination we could see, but in this combination you cannot find anything. At least 1 comma 2, the subset of the frequent items, it is also called as frequent item set. If you apply this rule 1 comma 2, 1 comma 2 they purchase only one time, and 1 comma 3 also they purchased only one time. Yeah, here the numbers are not visible. Anyhow, I will try to re-upload this one, okay, after I find you. So but with this pair, these at least one pair is purchased together, okay, hence yes. When you apply the minimum support count, the no will get discarded and only yes. These three items were purchased together. And similarly, if you take 4 items together, we started with 1 frequent item set, 2 frequent items, 3 frequent, and 4 frequent item sets. 1, 2, 3, 5. Right? So 1, 2, 3, 5, 1 comma 3, 1 comma 5, 3 comma 5. Okay, with this where the support is 1, only one time they purchased, right? So 1, 2, 3, 5. See 1, 2, 3, 5. Only one time they purchased, and if you apply the minimum support count 2 is at least 2 should be there. So hence this one will get. Okay. So likewise, iteratively, it will find the frequent 1, 2, 3, 4 items, right? And then this is how the algorithm works. Okay. Now let us jump into R and see. Okay, it is there already. It's very easy to perform this data set. Here, see in real-time scenario, you will not get the data set with the transaction data type. Okay, look here. Here, I imported a package A rules with and data sets. This is the built-in data set. Okay, this package has many data sets in it, the demo data sets. There is a function called data, method called data. There is something called groceries that is available as part of this library. Okay, you don't have to import it externally. It is available as part of this dataset package. If I use data groceries and class, if you look at this, it tells you very clearly it is a transactions data type. So far, you learned about the data frame, series, a data frame, like that kind of thing you learned. There is something else called transactions. There is something else called transactions. If the data type is a transaction data type, then applying the association rule on that transaction type of the data is very much possible. And with that, you can use the A rules function. Sorry, a priori function. You can use a priori function to find out the most frequently purchased items. Okay. See, this a priori, what this one is, right? It is iterately finding the frequent one, frequent two, frequent three, peak and four, and by applying the minimum support count, we can filter it out. So again, you have a control here, right? So if you wanted to see more than 3 times when the customer purchase together the items, I'm interested in only that one, right? Then you have a control here. You can say 0.007, but right, you can use, but it's a trial and error. You keep trying with different values, and then you can filter it out and then check it out, right? So the point here is the data set what you are using. It's supposed to be in the transactions type. It should not be data frame. Now the question is, in real time scenario, we are getting the data in Excel sheet. How can I convert the transaction? There is an option. There is a function method called as. The simple is, that's why I use a simple data. Okay, here I created one data frame. Okay, this data frame, and if I query this data frame, it is a data frame type, right? The type of this data is data frame. We store the data in data frame format. But if I have to use the A rules, association rule package, then I need to convert that as a transaction format. Look here. For that, as method is available, the first argument is your DF, and next, if you specify transaction, it will become transaction data set. Look here, it became a transaction. That's not data frame. This became a transaction. This is how. So once you convert this, that's it. You can blindly close your eyes and use the A rules library related functions. Okay, like item frequency, inspect rules, item frequency, all those things you can use it here. Now what we will do is I'm going to check the structure of this one because it is not a data frame. If you use str, it will not give you the readable format or the legible format of the data set because it is a sparse matrix. The transaction type of the data is sparse format. What is sparse format? It is an antonym of your dense data. Sparse data, dense data. Dense data is very thick, right? Dense forest. That means many trees are there. Sparse is here and there, trees are there, right? So it's a sparse matrix. The transactions type of file is, so obviously because one customer, listen, in one invoice, a customer purchased only one item. The other customer, in his invoice, we could see he purchased 10 items. For customer one item, customer two, 10 items will be there. Okay, but for customer one, the only one item is there, but the rest of the things, right, it will be blank, right? And some customer 10, some customers 15, some customers again 3, 2, 1. Since the data will be in this sparse format, and we have a function called inspect or function or method, so using which we can see the first 3 records in this data set: citrus fruit, semi-finished bread, margarine, ready soups, and tropical fruit. And these are the items are there. And we have something called item labels. So this kind of, the labels for each and every item, frankfurter, liver loaf, all the things are there. And if you use show groceries, it tells me 9,835 records are and 169 columns are there. If I multiply these two things, 9835 into 169, so how many number of records are there? So 1 million, right? 3 and 6, 1.6 million. 1.6 million columns are there, right? 1.6 million columns are there, or cells are there. If I look at this here, So it gives me different levels are there. So in meat and sausage, and the sausage, you have some meat and sausage, and these are Frankfurter, different brands for different things, right? A different sausage is available. You can see the label using item info, and level one also. If you want to check only level one, you can say. But the useful function is item frequency. Right, item frequency tells the Frankfurter, sorry, not item, yeah, frequency plot. Look here, the item frequency plot function. I just pass this data set as an argument. Top 20 frequent items. I want to see it. Look here. So this is what. So when I look at this, it is pretty clear that whole milk is purchased more frequently, the top purchased items. Other vegetables, rolls, buns, and soda, yogurt, these items were purchased most frequently. And if you want to see only the top five, you can just use the top N option. It shows you the whole milk, other rolls, buns, soda, and yogurt. And the next one is, I'm going to use a priori now. Okay, this is the a priori function or method is the one implements the association rule. Okay, it helps us to find out the items that were purchased together more frequently. Okay, the next I'm going to use something called summary rules. Summary tells me this one. So 1363 rules are there, and here this one tells me out of see, for 137 transactions, they purchase two items together. For 214 transactions, we can see that three items were purchased together. For 12 transactions, four items were purchased together. So rarely they purchase more items more frequently, right? So that's what we can see there. But here, three items they purchased. We could see that 214 transactions, three items were purchased together. This is kind of the support, confidence, the coverage, lift and all. And okay, anyhow, we will directly jump into by lift. Yeah, this is the one which gives me the rule, association rule, along with the support, confidence, and coverage. So here what it tells is the left hand and right hand side. The customer, whenever they purchase herbs, along with they purchase root vegetables also. And whenever they purchase berries, along with that they purchase whipped sour cream also. Whenever they purchased these three things together, they also purchase root vegetables. Right? And beef and other vegetables, they purchase along with this one. This is how you can generate the rules, right? By looking at this, by sharing this one to the management, you can right, you can, or you can recommend them. So these items are more frequently occurring, hence try to keep these items together in store. When it comes to digital online, right, recommend these items for those customers. They purchase tropical fruit, other vegetable, whole milk, recommend them this one. Or berries, whenever they buy berries, recommend them to buy this one also. See here, I used the same thing, but different support count, a 0.009, basically to find out the frequent items, or or discarding the less frequently items, you increase the support count. Okay, so that you'll be very sure by keeping the relevant items really makes sense. Inspect rules, so items, right? Inspect rules too. And if I use this one, it is throwing error. Okay, here. Okay, or else, right, you just refer this one. Okay, probably by reducing the value for support and confidence count, you will not run into this kind of issues. And in case of any, in case of any uh, pair is not identified, you will get into these kind of issues. Okay, and that kind of situation, you can use support count, reduce the support count value. See, in real time, we deal with humongous volume of the data. Plot, I don't know why it's not plotting it. It is in progress. Let's wait for some time. So you can also view it in the form of a graph. Okay, so I will share this code, and Python also I'll have to check. Okay, not much difference. Okay, the same algorithm. So this is how it works. Okay, 3 steps. Okay, step 1, step 2, and discover iteratively the new frequent again from until no frequent items are. As long as no frequent items are, you need to keep find out the frequent 1, 2, 3 k plus 1 item size. Okay, that is the whole idea of that thing. Again, so some problem with my this thing, the support count. Try with, I'll share this code also. They use different support count, but in real time scenario, very simple. You take your data frame and use as function. That is the beauty of R. Okay, and once you convert it as a sparse matrix, then you can use this package to plot the frequent items, and also you can use support count, confidence values to filter the less frequently bought items, right? That way it will be helpful. It's a very simple algorithm. Even the market basket analysis and time series also. The next one is neural network. What we will do is, right, neural network requires more time, okay, and also will cover the back propagation. That also will take time. What we will do is we'll take up the neural network tomorrow, and the deployment also takes time. Okay, so hence, if I continue now, the part of neural network now, and if I continue tomorrow, there will not be continuity. We'll take up both the neural network and the deployment part tomorrow. Make sure that you are not missing it tomorrow session, because it's a very important topic. As you all aware, the neural network is the basis for the deep learning part. Deep learning, they are making a lot of breakthroughs day in, day out, right? Many the pre-trained models also coming up like anything. Okay, and that is very important topic tomorrow session. Don't miss out at any cost. Okay, see, these are all very simple topic. Okay, but if you are looking for a job with a retail company, right, definitely they expect you to be good at MBA, market basket analysis, and also collaborative filtering. Collaborative filtering also will take up later. Okay, and will complete all the key algorithms, because neural network is very much important for deep learning algorithms. The plan is like this: tomorrow we'll continue the neural network. If possible, we'll complete the back propagation also. But yeah, few of you did not attend the gradient descent algorithm, right? In the case of back propagation, gradient descent algorithm is used. For that, you should know what is partial derivative, everything. So what we'll do is we'll cover the first part of neural network tomorrow, and then we'll cover the deployment part, and then followed by, see, next weekend we'll complete the back propagation as well as the support vector machine. Okay, and what else? And then you take 2 days break to complete the assignments. Tomorrow we'll discuss about the assignment also, because if I keep continue with algorithms one after another, you are also supposed to work with the assignments. Start work on it. and next weekend we'll complete majority of the algorithms. Okay, you start work on it, and we'll take 1 week break to review all the things, and then see next weekend. So what we will do? The plan is now itself. I'll tell you. So that next weekend, right? We'll take 1 day time, and what will December first weekend will complete the deep learning part and the NLP part also. The recurrent neural network, convolutional network, NLP also I'll complete it. 6 and 7. December first weekend we are going to wrap up. Okay, and also yeah, in case of additional session is required because within 2 hours or 2 hours we could not cover it because conventional will also take longer time and RNN also requires more time. We'll see to that. Okay, if that itself takes 2 days time, then we will take up the NLP later point in time. Okay, but we'll try to cover everything by first weekend of December. Okay. So next weekend, what we see, tomorrow is Sunday. The next weekend only you are going to work. I'll spend 1 hour, 1.5 hour time for back propagation. It requires 1.5 to 2 hours time. Okay, back propagation, and this Sunday you take a break, right? And you start work on all the algorithms and assignments, whatever I give it, complete it, and then we will circle back on 6th and 7th. We will complete the deep learning algorithm, and we'll try to complete the NLP also. Okay. Yeah, if required, we'll have some follow-up session, right? If you think you need some clarification, we'll have one session per week to address your questions. But make sure that tomorrow's session is very important, and back propagation next weekend also very important. Only 1 day next week, okay, next weekend, and 6th and 7th don't miss out. Very very important. Tomorrow's session also very important. Okay, from my side, I'm done with it. You have any questions so far? Yeah, if yes, any other additional algorithms, uh, can I get help? Yes, we'll cover the war part also, multivariate time series analysis. But first, we will complete whatever the syllabus that I promised to you, and then we will jump into other algorithms also. Okay, like the what is that? The var that is for multivariate time series. See, even now the forecasting also, most of them they use RNN, recurrent neural network. Okay, and conventional neural network used for image classification, the face recognition, everything. And this one, the RNN is used for next word prediction. In the case of Google search engine, if you type any keyword, it automatically tells you the next keyword, right? It recommends you the next keyword. Even if you make any spelling mistake while typing the keyword, it recommends you, is this what you meant, right? So that is possible because of RNN. And the NLP also will cover the sentiment analysis and summarize text summarization, and also will cover the pipeline, the NLP pipeline. Yeah, one more thing is pending, the machine learning pipeline. That also will finish it off next weekend. Okay. Yeah, next Saturday we'll continue with the back propagation and the machine learning life cycle. You should be knowing it, right? What is like software development life cycle, and when it comes to machine learning algorithm, how do you? So as part of that, we'll cover the NLP pipeline also. Anyhow, we'll be discussing it pipeline and all tomorrow session also as part of CACD and all. Okay, we will that time we will get to know. So these assignments, whatever I'm talking, will help you to work on the complete the pipeline, machine learning pipeline. Any of the business cases given, you don't have that headache. But when it comes to real time scenario, what we do is we are supposed to identify the business cases, compelling business cases, and we need to prioritize. We are supposed to prioritize. We need to justify the business stakeholders the benefit of implementing that model, and then get their buy-in in order to implement those initiatives. That is a big challenge. Okay. Fine. Since none of you have asked any further question, we'll wrap up the session now. We'll circle back tomorrow, but don't miss out tomorrow's session. Okay. Okay. Good night and have a good day. Take care.
Thank you, Satya.
Yeah.
Good night.
Okay, so in the case of time series, before we jump in, okay, and this model is this. This is kind of the support